As a scientist or as a mathematician, you have to work with very large and very small numbers, which are sometimes difficult to get your head around. To make things easier, scientific notation was developed. Scientific notation is a systematic shorthand way to write very large and very small numbers so they're easy to understand. Let's have a look at some examples.
The number 1000, while not a huge number, can be written as 1 times 10 to the power of 3 in scientific notation. In order to get that, we need to remember that there's a decimal point after the number, even if it's not written. We first need to figure out, if we move this decimal point, what number between 1 and 10 would the number 1000 become? Well, if we move the decimal point 1, 2, 3 places back and put it here, the number 1000 becomes the number 1. And that's what we write down first. And by the way, this number can't be 10, it has to be less than 10. Now this number is always multiplied by 10 to the power of something, and because we've moved the decimal point 1, 2, 3 places back, this number, called the power or exponent, is 3. Some of you might already know that a power or exponent of 3 above the number 10 means 10 multiplied by itself 3 times, so 10 times 10 times 10. This time we'll look at converting a larger number like 1 million. So remember, the decimal point is here. To convert 1 million to a number between 1 and 10, I need to move the decimal point back 1, 2, 3, 4, 5, 6 places. This gives me the number 1, which is between 1 and 10. Now we know that this number is always multiplied by 10 to the power of something, and we've moved the decimal point back 6 places, so the power, or exponent, must be 6. Now let's have a go at a number that doesn't convert neatly to a 1 times something. For example, 125,000. So there's the decimal point, and I need to move it so that 125,000 becomes a number between 1 and 10. If we move it back 3 places, we get 125, which is not between 1 and 10. Going back 1 more place, that gives us 12.5, which is still not what we want. But back 1 more, and we get the number 1.25, which is between 1 and 10. So we write 1.25 times 10. And the exponent must be 5 because we moved the decimal point back 5 places. So all of these examples are big numbers greater than 1. And because of this, these numbers, the exponents, are all positive. They're greater than 0. However, we don't write the plus sign. This is unnecessary. Before we move on, while it's fresh in your mind, pause the video here and have a go at converting these numbers to scientific notation. You'll be able to see the answers at the end of the video after we've done a few more examples. Next, we're going to have a look at some examples of converting very small numbers, numbers less than 1, into scientific notation. First, let's try 0.001. We can already see the decimal point here, so there's no need to imagine it. Now we want to convert this really small number into a number between 1 and 10. So we move the decimal point to the right 1, 2, 3 places. This gives us 1, and as always, we need to times it by 10 to the power of something. Now because we move the decimal point to the right, not the left, the exponent becomes negative, and we move the decimal point 1, 2, 3 places, so it's negative 3. 10 to the power negative 3 means 1 divided by 10 3 times. Let's try 0.202. There's the decimal point. Now if we move it all the way to the end, like in the last example, that would give us 202, which is not between 1 and 10. So instead we move it just 1 place to the right, which gives us 2.02. So we write 2.02 times 10, and we've moved the decimal point 1 place to the right, so the exponent is -1. Let's try one more small number with lots of zeros, 0.000075. The decimal point is here, and we need to move it 6 places to the right to give us a number between 1 and 10. This gives us, in scientific notation, 7.5 times 10 to the power of -6. So that's how we convert numbers to scientific notation. Pause the video here and have a go at the examples. Then check the answers to these questions and those that we did earlier.